Hi friends, welcome to my channel. In today's class, we will discuss how to draw an involute by using the given data. Let us take here a disc is in the form of a square of side 30 mm. One disc has given, it is looking like square. Each side of the square is 3 cm or 30 mm. So roughly I am doing here, one square has given, it has 4 sides, all sides has equal length, that is 30 mm. Okay. Surrounded by a semicircle on one of the sides of the square. One side of the square is one semicircle. So I am taking this side. It has one semicircle, means half of the circle. What is the diameter of this? It is also 30 mm. It is side length of the square. So surrounded by a semicircle on one of the sides of the square and a half hexagon on the opposite side. On the opposite side of the square, half hexagon is there. Hexagon means it has 6 sides. Half hexagon means 3 sides. So one side is semicircle, one side is hexagon, half hexagon. One side is half hexagon, here one side is semicircle. So this is a given disc. Okay. Draw the path of the end of a string which is unwound from the circumference of the disc. Circumference of the disc means total length. Okay. On total length in the given disc, here one string has given. String means it is a wire or rope or thread like that. Let us take, we are keeping starting point here. Okay. Starting point of the string here. So the next end is here. Okay, the length of the string is circumference of this given disc. Circumference means this length plus this length, this length, this length. The entire length, we have whatever length is coming, total sum, it is equal to length of the string. Okay, if we are winding around it, it is coming starting point and end point of the string will come here. Let us take this point is P point, this point is Q point. Both P and Q are coming at the same point. If we are winding this string, okay, the length, whatever length is there, it is equal to sum of all the lengths of the disc. Okay, it is completely P and Q are coming here. Okay, during winding, here we need to draw the path of the end of the string which is unwound from the circumference of the disc. Okay, after winding, I am taking P point as it is. I am fixing that point, and the next this point is coming like this. Okay, during unwinding, like this. It is called involute. We have to do this diagram. For doing this diagram, first we will do the disc. In it, initially take the square of 3 cm. By using drawing instruments, we will do here. Let us do the square of 3 cm. This is the starting point, 3 cm each side of the square. Next side is 90 degrees. Okay, for getting 90 degrees, I am using set square. Okay, one side is coincide here. The another side is 90 degrees. So how much this length? 3 cm. Okay, this side also take 90 degrees. On this side, take 3 cm. Okay, remove the extra end. Now join these 2 points. So this is the square. Now one side of the square has semicircle. First initially do the center here. So in 3 cm half means 1.5. Okay, from this side, mark the center. This is the center, 1.5 cm. Now this is center, this is the radius. Do one semicircle. Okay, this is the semicircle one side. Here we need to do the hexagon. Okay, we don't know how much each side of the hexagon. For that, I am taking one circle. Okay, inscribe circle method, one method is there. In it, we have to take one circle initially. In it, we can insert this hexagon. Okay, like roughly I am doing here, like this. One hexagon will be coming inside the circle. So here I will do the circle which is passing through these 2 points. It is the diameter. Okay. For doing the circle, here I did one center line. Center line means it is 3 cm, 1.5 this side, 1.5 this side. This intersection point is center. This is the radius. I will do one circle. Why I am doing circle? For inserting the hexagon. Like this. Okay, in this circle, we have to keep this part of the hexagon. Okay, we have to keep this hexagon. Okay, now here for doing the hexagon, what I am taking? So let us take, this is the hexagon. Okay, we have to keep half of the hexagon in this circle. Okay, here. Now for it, we have one outer angle formula. Take any horizontal or any length of the, okay, just extend it. Whatever this angle, the same angle this side also. Okay. Now how much this angle? We have one outer angle formula 360 by n. Okay, this angle formula. And similarly this angle formula also 360 by n. Here also the same formula. Here also the same formula. Okay, outer angle is same at all corners. 360 by n means 360 by n means number of sides of the polygon. Here for hexagon it is 60 degrees. Okay, so this is 60 degrees. For getting this angle, how much this angle? Because we know this one of the corner. Okay, for finding this, just take one right angle triangle. This is 60 means this is 90. And what about this angle? As so in any triangle, the sum of all angles should be 180. Okay, so this is outer angle is 60 degrees plus this is 90, and we need to find this angle. Let us take theta. Sum of all the three angles in this triangle is 180. Okay, we need to find this value. Theta is equal to 180 minus 60 plus 90 means 150. How much this angle? 180 minus 150 means 30 degrees. So this angle is 30. Similarly, this angle also 30. Okay, here what I am doing, I will do 130 degrees line, here also 130 degrees line. Okay, how to take angles? By using the set square. Here I will take 30 degrees. Okay, like this. So in this direction I will do one line. So this is 30 degrees point. I will join this point to, in this direction, one line. I will do one line like this inside the circle. This is one side of the hexagon. To this line also, how much this angle? Outer angle 30 degrees with the horizontal. So with the horizontal, here take 30 degrees like this. Okay, now join this point to this point, extend the line within the circuit. Now here we will get another side of the hexagon. So we got two sides. Join these two ends. We will get the third side of the hexagon. Just take this is the reference line, move the scale, forgetting the parallel line. Now join these two ends. Three sides of the hexagon. Okay, half of the hexagon. Remove this circle. It is not necessary now. Now this is the required disc like this. For it, we need to take one string, okay, one wire. So that wire length is equal to circumference of this disc. How to find circumference of this disc? So circumference means entire length of the disc. Okay, initially start from here. This length, how much it is? 3 centimeter. Okay, plus how much this length? Let us check by using scale. This is 1.5 centimeter. Okay, so all three sides are same length because it is a regular hexagon. So 1.5 plus 1.5 plus 1.5. So 3 into 1.5 plus this value 3 plus this circumference. So for total circle circumference 2 pi r. For this half circle pi r. Okay. So pi into r means radius of it. How much it is? Half in the 3 centimeter. Okay, 1.5. So pi into 1.5. This is the entire length of this given disc. This length is equal to the string length also. Okay, string length L. Let us take our PQ length. Okay, PQ is a string. So it is length of the string. So calculate by using the calcee here. We got this length is 15.2 centimeter. Let us take 15 centimeter. It is length of the string. Let us take the string like this. Okay, of length 15 centimeter. Here I did one horizontal line. On it I will take this length 15 centimeter. This is the starting point. Okay, and now 15 centimeter is the end point. Join these two. It is a string. Okay, I am giving the name PQ. This is a given arrangement of the disc and string. Divide this semicircle into some parts. Okay, so I will divide this semicircle into 6 parts. Okay. For dividing it, how much this angle at center of the semicircle? 180 degrees. So we have to divide this 180 degrees into 6 parts because we are dividing into 6 divisions, equal divisions. So each angle is 30 degrees. Okay, let us take this is the reference. Start from here like this. So each angle is 30 degrees. Okay, let us take from here from 0 to 30 degrees. Mark here. Next, now 30 plus 30 means 60. At 60 to 1 point. Next 60 plus 30 means 90 here. 90 plus 30 means 120 here. Okay, 120 plus 30 means 150 here. Okay, now join all these points to the center and do the lines. Okay, within the circle, so that we will get the divisions. Initially take this point 30 degrees, join to center by using scale. So do the line within the semicircle. First part, and next point join this point to center, do the line, and here this line, and already we did the axis line here like this, and next point here. After this next point is here, so in this direction do the line like this. Now these are the 1 2 3 4 5 6 parts. Let's give the numbering for this disc. Okay, start from here. I am giving this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, 7. At all corners I am giving numbers. This is 8, this is 9, this is 10. Okay, at P point I am giving 11 also. Okay, P comma 11, both are at the same point. Okay, from 1 to 11 I have given the numbers for all the disc corners. Okay, now mark these points on the string also. Okay, so initially mark 1 from the starting point, how much it is. So here I have written it is 3 centimeter. This circumference length semicircle pi r, it is 4 pi into 1.5 radius, pi r means it is 4.7 centimeters. And here this is how much length, 3 centimeter, and this is how much length, each side is 1.5 centimeter. This is 1.5, 1.5, 1.5, total 4.5 centimeter. Okay, now start from 1. So how much distance it is, 3 centimeter. So on the string mark 1 at 3 centimeter. At 3 centimeter mark this point. Okay, this point is 1. Instead of 1 I am taking 1 dash. Now after 1 dash, how much length we have to mark, 4.7 centimeter. From 1 dash take 4.7 centimeter on the string. Okay, this one. What is this value for after 4.7? 7. Okay, this is 7 dash. Here in it we will get the equal number of parts. How many parts? 6 parts will come. We have to divide this space into 6 equal divisions. Initially we will mark these lengths. After that we will do at the end 6 parts. Okay, after that, after getting 7, so after getting 7, after that this is square length 3 centimeter. Mark 8 at 3. Okay, so from 7 dash mark 3 centimeter. So after 8 dash mark 1.5, 9 from 8. Next 1.5, next 1.5 here. Okay, so I am marking 1.5, 1 point from 8 to 9. Okay, give this is 9. After 9, 1.5, 10. Already we have marked here 10. And then P11, 1.5. Already this is 1.5. So Q at Q point 11 is also coming. Okay, so I have marked all the points. Now let us divide this 1, 7. So this length, let us divide this length 1, 7 length into 6 equal divisions. Okay, how to divide this length into 6 equal divisions? 4.7 do with classee divided by 6 parts. How much? Let us check by using classee. It is 0.8 centimeter. So let us start here, take 0.8, again 0.8 like that. Mark all these points. By using scale, mark all the points. Now from this point, take 0.8. 0.8 plus 0.8 means 1.6. 1.6 plus 0.8 means 2.4. Okay, so 2.4 plus 0.8 means 3.2. So 3.2 plus 0.8 means 4. Okay, 4 plus 0.8 means 4.8 here. Okay, so these are the divisions. Give the numbering. So from 1 to 2, this is 2 dash, this is 3 dash, this is 4 dash, this is 5 dash, this is 6 dash. Okay, we have marked all these points from 1 to 7 on the linear length. Okay, and 8, 9, 10, 11 already we have marked here. Okay, these are the points on the string. So after getting these points, here let us take this side up to some length. Okay, from all the sides we have to do the lines of some length like this. Okay, do up to some length. So in this direction also do the line of some length. Now here also already we did the string length. So same thing, string length we are taking here, here. In this direction do the line of some length. And from 7 also do the line like this. Similarly at 6 also do the tangent. Here for the curved one we have to do the tangent. Tangent means, so let us take this is 0. 0 to 6 we have to take one line. So take the set square. One side of the set square is coincide with this 0, 6, and with another side do the tangent. This tangent is 90 degrees to this radius. Okay, from 6 it is a tangent. Tangent means this line is touching the circle at 6th point. Okay, similarly at all the points, do the tangents. So similarly at 0, 5, keep the set square like this. Now here do the perpendicular. Okay, so this is at 5. At 4 also do the line. Do up to some length. Okay, now at 3 also do the perpendicular line of some length. Okay, like this. And at 2 also do the line, tangent. So similarly at 1 we did the tangent here already. Okay, at 1 and 11 we did the tangent here. Okay, from all the points we are doing the string length. Okay, it is not equal to string length, just we did the some length of the lines. For the curved section we did the tangents. Okay, at all the points. So after doing all the lines from the sides and tangents from this curved section, here initially mark P11 length, means total length here, P11 length. Okay, so P11 is coming here. And now next is after P11 mark P10 length, P10 on this line. Take P10 length by using compass. Okay, mark from 10. Take the bigger arcs so that we can join easily. Okay, so take this is P10. After P10, take P9 on the 9th line. P9 dash length. Mark on the 9th line. 9 as center. Do an arc. Okay. Now mark this intersection point is P9. After P9, mark P8 on 8th line. Take this P8 length. Okay, by using compass. P8 dash length. Mark on the 8th line. 8 as center. Do an arc. Okay. So take intersection point P8. Similarly, on 7th one, take P7 radius. Take P7 dash length. On the 7th one, mark this length. Okay, it is P7. Similarly, after P7, mark P6 on the 6th line. Take P6 dash length. 6 as center, mark P6. Okay, mark that point as, take the intersection point P6. After P6, take P5 on the 5th tangent. By using compass, take P5 dash length. Now 5 as center, do an arc. So it is coming here. Okay, give the intersection point is P5. After getting P5, take P4. Mark on the 4th tangent, which is passing through 4. By using compass, take P4. P4 length, mark on the 4th tangent. 4 as center, do an arc. Take that point as P4. After P4, take P3, mark on 3rd line, 3rd tangent. Take P3 length by using compass. Okay, mark on the 3rd tangent. 3 as center, just do an arc. So extend the line here, tangent, so that we will get the intersection point. So I have extended the tangent. This is the P3 intersection point. After P3, mark P2. So take P2 length. Take P2 length. Mark on the 2nd tangent. 2 as center. Just do an arc here. So this is P2. Okay. Mark after getting P2. Mark P1 is coming here only. Okay. So it is P1 also. This point is. Okay, because we did tangents at all the points. Okay, similarly at this sides we did the lines like this. So from 1, let us assume we are doing the line here. So P1 is coming here, P1 here only. We got all the points P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11. Now join all these points by using the freehand curve. Okay, let us do. I am joining P2. Here I am joining P1 to P2. So it is coming here by using freehand curve. After that P2 to P3. After that P4 to P3. After that P5 to P4. P5 to P6. After that P6 to P7. P7 to P8. P8 to P9. So P9 to P10. And then P10 to P11. Like this. So this curve is called the involute for the given disk. Make this curve should be in dark color, and this diagram should be also in the dark color compared to all other lines. Okay, this curve is called involute. Okay, and after getting the involute, mark the given dimension. What is the dimension given? Square length has given. Each side of the square length, how much it is? 30 mm. Outside the diagram, extend the lines here at the dimensional line at the center. Just take one small square and mark 30. The meaning is each side of the square is 30 mm. No need to mark all the four sides. Okay, this is the method of doing an involute for the given disk. So other video lectures of involutes I give in description box. Please check it. If you like this lecture, hit the like button, subscribe my channel and share with your friends. Thank you for watching.